Chapter 9. Diseases of Ornamental Plants. Learning Objectives. After study of the material in this chapter, you should be able to name the 4 types of pathogens that cause the majority of plant diseases. Explain the difference between protectant and systemic fungicides. Define fungicide resistance and explain how to slow the development of resistance. Know the general symptoms associated with common foliar and root diseases. Terms to know. Bactericide. Broad spectrum. Pathogen. Protectant aka contact fungicide. Systemic fungicide. Local penetrant aka local systemic. Fungicide. Mode of action. Resistance. Leaf spot. Scab. Root rot. Nematode. Powdery mildew. Blight. Vascular wilt. Solarization. Chapter 9. Diseases of Ornamental Plants. Successful disease management for ornamentals requires much more than spraying pesticides. By the time disease symptoms appear or become severe, it is often too late to provide effective control. For this reason, prevention is not only the most important method of disease management, it is often the only effective control. To avoid plant diseases, review Chapter 6 for ways to grow healthy plants that are better able to withstand disease damage. With careful cultural management, most landscape plants can be grown using little or no pesticide. In addition to disease, many factors cause plant problems with symptoms that resemble those caused by plant pathogens. Symptoms that are actually caused by overwatering, nutrient deficiencies, pesticide toxicity, air pollution, and improper plant selection are often incorrectly blamed on insects, mites, or plant pathogens. Review the disease pyramid section of Chapter 5. Remember that disease occurs only in the presence of 1 a pathogen to cause the disease, 2 a susceptible host plant, 3 environmental conditions that favor disease development, and 4 time for infection to occur. Most plant pathogens require specific conditions to spread and infect plants. By modifying these conditions, you may be able to prevent the disease from spreading. Types of pathogens and pesticides. The microorganisms that cause diseases are called pathogens. The most common pathogens that cause diseases of ornamental plants are fungi, bacteria, viruses, and nematodes. Fungi are responsible for most plant diseases in the landscape. They cause a variety of plant symptoms including leaf spots, wilts, dieback, root rots, and cankers. Although you need a microscope to see most fungi, some of them, such as powdery mildew and rust, are visible without magnification. Fungicides are applied for control of some fungal diseases. Bacteria are one-celled, microscopic organisms that can cause shoot blights, leaf spots, soft rots, and galls. Bactericides are used to control bacterial diseases, but in most cases once symptoms are seen, the damage is done, and it is difficult to stop disease development. Viruses are pathogens that are too small to see even with a microscope. Viruses can cause stunting, discoloration of leaves and flowers, or malformation of plant tissues. Viruses are most often introduced into a landscape on infected plants. Aphids, leafhoppers, or thrips spread many of the common plant viruses. No pesticides are available for virus control, although some insecticides control the insects that transmit viruses. Plant parasitic nematodes are microscopic roundworms. Various species attack roots, root parasitic nematodes, shoots, stem nematodes, or leaves, foliar nematodes. Nematodes that attack the roots can cause root galls, stubby roots, low vigor, discoloration, or decline of infected plants. Foliar nematodes cause a discoloration of leaf tissue and infested leaves drop off. Fungicide basics. Protectant fungicides. Most of the pesticides applied to ornamentals are fungicides used to control fungal diseases. A few bactericides are used for control of bacterial diseases. Some fungicides work against specific pathogens, while others are effective against a wide variety of pathogens, broad-spectrum fungicides. Most fungicides and bactericides are protectants that act like an exterior shield that protects the plant from certain fungi or bacteria for some period of time. When the fungus comes in contact with a protectant fungicide on the plant surface, it is prevented from entering the plant and causing infection. For this reason, protectant fungicides are also called contact fungicides. Protectant fungicides do not enter the plant, but stay on the leaf and stem surfaces. Because protectant fungicides and bactericides are effective only on contact with the pathogen, it is important to coat the entire surface of the plant to provide a complete shield. This means that young, expanding leaves and twigs may need to be sprayed more often than mature tissues, since they may outgrow protection within 3 to 5 days after spraying. The duration of protection that a protectant fungicide provides depends on many factors. As with any pesticide, rainfall or irrigation within a few hours after application washes away much of the pesticide residue and greatly reduces the protective value. Even after drying on the plant surface, residues of a protective fungicide may continue to be eroded by rain, dew, vaporization, or sunlight, thus reducing the protection. Systemic fungicides. Systemic fungicides are absorbed and translocated within the plant from the site of application to distant tissues. This means that systemic fungicides can prevent the development of disease at the site of uptake and in other regions of the plant. Almost none of the fungicides on the market today translocate throughout the entire plant. Most systemic fungicides are only translocated upward in the plant's water-conducting vessels, xylem. Local penetrant, also called local systemic, fungicides are absorbed into the immediate area of application, but are not translocated far from the site of uptake. Some local penetrant fungicides move through the leaf tissue from the upper surface to the underside of the leaf. These are useful when it is difficult to get good spray coverage on the bottom of the leaf. Because they are absorbed by the plant and protected from wash-off and weathering, systemic fungicides have longer residual activity than protectant fungicides. Systemic fungicides also protect plant tissues such as crowns, roots, and newly formed tissues that are difficult to spray. They may also control fungi that have already entered the plant, although preventive applications of systemic fungicides are generally more effective than treatments applied after infection has occurred. The main problem with systemic fungicides is the development of pathogen resistance or tolerance. Fungicide resistance. The mechanism by which a fungicide or bactericide controls a plant pathogen is called its mode of action. Most fungicides target specific processes that the fungus needs in order to survive. If the fungus is no longer killed by the fungicide, the pathogen is said to have developed resistance to that fungicide. Fungi that have developed resistance to a fungicide will no longer be adequately controlled by that fungicide or any fungicide with the same mode of action. Compared with systemic fungicides, protectant fungicides tend to affect fungi in multiple ways, which makes it more difficult for the fungi to develop resistance and get around the chemical. Because many systemic fungicides target just a single process in the fungus, the pathogen can more easily adapt its metabolism in order to survive and develop resistance. It is very important to read the precautions on pesticide labels and follow the recommendations for managing resistance. This usually means limiting the number of consecutive applications of the same pesticide or limiting the total number of applications of the same pesticide in one season. Using fungicides that act in different ways on the pathogen will slow the development of resistance. Soil fumigants. Some chemical fumigants are used to sterilize soil by killing most fungi, bacteria, insects, nematodes, and weeds. Fumigation for disease control is generally limited to situations where populations of soil-borne pathogens have reached such high levels that susceptible plants can no longer be grown successfully. Fumigants are applied as a gas or a liquid injected into the soil and immediately covered with plastic or as granules that are incorporated into the soil, typically followed by irrigation, and then covered with plastic. Fumigants can be highly toxic to humans and must be used with strict safety measures. Fumigants are restricted-use pesticides. Fumigants cannot be applied where plants are currently growing, so their use is generally limited to large, commercial landscape beds that are replanted each year or to areas where high-value ornamentals are being produced. Types of disease. Examples of the most common types of diseases of ornamental plants are described in the following pages. Management sections include preventive methods and other control techniques for each disease. Leaf spots. Leaf spots may be caused by pathogens, environmental conditions, cultural practices, and insects. Most ornamental plants are susceptible to one or more fungi that cause leaf spots. Leaf spot fungi generally cause circular or irregular lesions on the leaves. Lesions are typically brown, yellow, reddish, or purple and may have tan or light-colored centers of dead tissue bordered by a distinct margin. Raised, pinhead-sized, black dots may be observed within the dead tissue. These structures are fruiting bodies that contain large numbers of fungal spores. Fungal leaf spots typically show up first on older leaves during periods of warm, humid weather. Water must be present on leaf surfaces for 4 to 12 hours, depending on the pathogen, for most fungal spores to germinate and infect the plant. Common fungal leaf spot diseases include Entomosporium diplocarpon leaf spot of Indian hawthorn and redtip photinia, black spot of roses, spot anthracnose on dogwood, shot hole on cherry laurel, and Cercospora leaf spot of pansy. Bacteria can also cause leaf spots. Leaf spots caused by bacteria often appear water-soaked and turn brown. The leaf spot may have a halo of yellow tissue surrounding the spot. English ivy, cherry laurel, and chrysanthemum are commonly infected by bacterial leaf spot pathogens. Blossoms and stems can also become infected and may wilt and then die. Management. Keep the foliage of susceptible plants as dry as possible, especially during warm, humid weather. Water with drip irrigation or irrigate in the morning so that the foliage dries out during the day. Give plants enough space to allow good air circulation between plants. Remove and dispose of spotted, fallen leaves. Fungicides or copper-based bactericides can be applied during periods of warm, wet weather to protect new growth. Scab. Scab is a common fungal disease that causes defoliation and blemishes on fruit. While the fungus that causes scab on apple and crabapple is different from the fungus that causes scab on pyracantha, the diseases they cause are very similar. Dull, olive-green, fungal growth that develops on the surface of leaves during the spring gives them a velvety appearance. Heavily infected leaves may turn yellow or reddish and drop prematurely. Infected fruit have circular rough spots on their surface and, in severe cases, the fruit can become completely covered with cracked, scabby, dark lesions. The scab fungus overwinters in infected plant tissue and in infected fallen leaves and fruit on the ground. Spores from these tissues are splashed by rain or forcibly shot out of fungal fruiting bodies onto young, emerging leaves the following spring. Young leaves that have moisture on them become infected. New spores that form on the infected tissue spread this disease throughout the growing season. Although apple scab does not do permanent damage, losing leaves 2 or 3 years in a row can weaken the tree. Management. Select resistant cultivars. Rake and destroy the fallen leaves and fruit under infected trees. The disease can be managed by fungicide applications made at 7 to 10-day intervals beginning when the leaf buds begin to swell in the spring and repeated until dry, warm summer conditions occur. Root rots. Several root and crown diseases commonly affect landscape trees and shrubs. These include armillaria root rot, Phytophthora root rot, and black root rot caused by the fungus Thioleviopsis. Because plant roots transport water and nutrients to the rest of the plant, the symptoms of root disease are also likely to be seen on other parts of the plant as well. Most of the fungi that cause root diseases are naturally present in the soil, so that the most effective control is to keep plants vigorous with proper cultural care and to prevent the wet soil conditions that promote disease development. Phytophthora root rot is a common problem on azalea, rhododendron, camellia, and boxwood, and it can infect more than 900 other plant hosts. Phytophthora kills the roots and root crown of infected plants. All species of Phytophthora require extended periods of high soil moisture to cause disease, so avoid overwatering and poor drainage. Infected plants are often stunted, have small leaves, and the roots are brown and rotted. At the base of stems near the soil line, infected wood under the bark is brown instead of a healthy white. Leaves may wilt and plants may appear to die suddenly when hot, dry weather begins. The roots of resistant cultivars that have been stressed by drought or flooding become susceptible. Management. When setting out plants in a new landscape, select resistant cultivars. Choose healthy, disease-free plants. Avoid plants that lack normal green color. Knock plants out of their pots and avoid plants with dark or discolored roots. In areas where root rot susceptible plants have died, replant with plants that are not susceptible to root rot. Remove and destroy plants confirmed to be infected with Phytophthora. Always locate plants susceptible to root rot in well-drained areas. In heavy clay or poorly drained soils, plant in raised beds. Incorporate organic amendments such as pine bark to a depth of 8 to 12 inches. There are no fungicides that can cure an infected plant, they will only delay an almost certain death. It is sometimes possible to treat uninfected nearby plants with a registered fungicide to protect them from infection. Nematodes. Nematode infestations of the roots should be considered whenever a particular plant species shows a general decline or stunting and yellowing or bronzing of the foliage. Root rots and poor cultural care can cause very similar symptoms, so an accurate diagnosis is important. Japanese holly, juniper, aucuba, and boxwood are often infected by root parasitic nematodes. Laboratory analysis of a soil sample is the only way to determine the presence and species of nematode associated with the problem. Contact your local county extension agent or the State Department of Agriculture for more information on testing for nematodes. Although nematode root feeding causes plant stress, established woody plants are rarely killed by nematodes. However, a plant that is weakened by nematode damage can be more susceptible to infection by more aggressive pathogens. In a plant bed, nematode damage may be spotty because nematodes are usually not evenly distributed throughout the soil. Foliar nematodes cause areas of discolored tissue between the major leaf veins. The infested tissue is initially chlorotic, discolored, but becomes dark brown with age. Heavily infested leaves will drop. Management. Select top-quality, resistant cultivars. Incorporate organic matter into the soil before planting to encourage the activity of other microorganisms that are natural enemies of nematodes. Tilled, moist soil can be treated through solarization, heating to very high temperatures that kill nematodes, by covering it with clear polyethylene for 6 to 8 weeks. Solarization works best on sandy soils in hot weather. Where the soil has extremely high numbers of plant parasitic nematodes, the soil can be replaced. This might be practical in planters and confined beds. Keeping water off the foliage will help to reduce the population and spread of foliar nematodes, but there is no cure. The best management practice is to avoid introducing infested plants into the landscape. Powdery mildew. Many ornamental plants are susceptible to one or more species of powdery mildew fungi. The first signs of powdery mildew are patches of white powdery-looking fungal colonies on the leaf surfaces and stems. Infection is favored by cool nights with high relative humidity, above 85%, followed by warm dry days with temperatures between 70 degrees and 80 degrees Fahrenheit, but powdery mildew can occur in humid as well as dry locations. Unlike most other fungal leaf spot diseases, free water on the leaf surfaces will often minimize disease. Crabapples, crepemyrtle, dogwood, rose, euonymus, and zinnia are often infected with powdery mildew. Infected leaves may become puckered and distorted. New growth may become twisted and deformed, and infected flower buds do not open properly. Once powdery mildew growth is extensive, it is usually too late for fungicides to prevent damage. Management. Selective pruning to increase air movement around the plant will help to reduce the humidity. Pruning out heavily infected plant parts will reduce the amount of inoculum that can start new infections. When choosing new plants for the landscape, select resistant cultivars. Powdery mildew grows best in the shade, so growing susceptible cultivars in sunny locations may help to prevent this disease. Apply a registered fungicide as soon as new growth begins to emerge or when fungal growth is first observed. Continue to make regular fungicide applications until conditions are no longer favorable for infection. Blights. Fire blight is an example of a bacterial blight disease that infects plants in the rose family such as apple, pear, hawthorn, and cotoneaster. Fire blight is evidenced by a sudden wilting and blackening or browning of shoots, blossoms, or fruit. Infected shoots appear scorched, and dead leaves remain attached to the twigs. Cankers may form on the twigs and branches which may die back. Branches and trunks may become infected when the bacterium moves downward in the plant from infected flowers, twigs, and shoots. The bacteria overwinter in plant tissue around cracked, sunken cankers on infected trees. During warm, wet, or humid weather, bacteria ooze from around the cankers. They are then spread to wounds or flowers by many species of flying or crawling insects, splashing rain, or pruning tools. Infection occurs through the blossoms. Once flowers are infected, the bacterium can be spread from one flower to another by bees and splashing water. Fire blight may kill susceptible cultivars if cankers develop in the main trunk. Management. Plant resistant cultivars and prune out all infected twigs and cankers before growth starts in the spring. Make cuts 4 to 6 inches below any evidence of dead tissue. During the growing season, make pruning cuts 12 inches below a canker or blighted tissue. Disinfect pruning tools frequently. Fertilize sparingly to minimize excessive succulent growth. Timing of bactericide antibiotic applications is critical for effective control. Applications of registered bactericides should begin several days before the first flower buds open and continue every 4 to 5 days until petal fall. Repeated use of antibiotics may result in the development of strains of the bacterium that are resistant and can no longer be controlled by the treatment. Vascular wilts. Various fungi and bacteria can cause vascular wilt diseases of ornamentals. Wilt diseases are usually fatal, and young plants can be killed quickly. Older plants may take several years to die. Dutch elm disease, fusarium wilt of mimosa, and laurel wilt are examples of vascular wilt diseases. Symptoms of bacterial leaf scorch occur during mid to late summer and symptoms are very similar to those of other diseases and cultural problems, so ask a diagnostic laboratory for confirmation of this disease. Wilt pathogens disrupt the vascular system that transports water and nutrients to different plant parts. The vascular tissues often turn brown and become clogged with fungal hyphae and spores, bacteria, or other substances produced by the plant in response to infection. The needles or leaves may begin to fade, turn yellow or brown, and then wilt. Management. Preventive fungicide applications can be made to highly valued trees to help prevent Dutch elm disease, but bactericides are ineffective in controlling fusarium wilt and bacterial leaf scorch. Test your knowledge. 1. Stunting, small leaves, and nutritional deficiency symptoms are all associated with what type of disease? A. Leaf spot. B. Root rot. C. Root parasitic nematodes. D, B and C. Answer: D, B root rot and C root parasitic nematodes. 2. Leaf spot diseases. A. Are usually worse in wet or humid weather. B. Cannot be prevented with fungicides. C. Can be managed with overhead irrigation. D. Are all caused by fungi. Answer: A. Are usually worse in wet or humid weather. 3. Root parasitic nematodes. A. Cause a general decline or stunting. B. can be brought to the surface by using soapy water. C. Are slender worms about 2 inches long? D. Cause more damage under cool temperatures. Answer: A. Cause a general decline or stunting. 4. Powdery mildew on crepemittle can be managed by several methods. Which of the following methods would not be effective? A. Planting a resistant variety. B. Using a soil sterilant to kill the spores. C. Spraying with a registered fungicide when symptoms appear. D. Spacing plants to improve air circulation. Answer: B. Using a soil sterilant to kill the spores. 5. Which of these statements about root rots is true? A. A fungicide can be applied to cure infected plants. B. Root rots can be controlled by flooding the plant bed to drown the fungus. C. Roots infected with Phytophthora are yellow. D. Most root rots can be avoided with clean plants and good drainage. Answer: D. Most root rots can be avoided with clean plants and good drainage.